This is RK and you are watching VIDHYA 4VIKAS Academy channel, and today we are going to deal with a chemistry topic of class 11th, that is the postulates of kinetic theory of gases. So there are approximately 9 postulates are there. So in that first one, every gas we'll write, then we will write every gas consists of a large number of tiny particles called molecules. So this is the first point. According to kinetic theory of gases, every gas consists of a large number of tiny particles which are called as molecules. Now coming to the second point. So now we discussed about molecules. Now we will consider as the gas molecules are considered hard, okay, spherical and perfectly elastic. Okay, so here we discussed about the molecules. Now we are telling the nature of the molecules. The gas molecules are considered hard, spherical and perfectly elastic. Now coming to the third point. The gas molecules moves in all possible directions. This direction, this direction, this direction, this direction, this direction. Okay, along a straight line path with very high velocities. So whatever the direction they will go in a straight line with high velocity. Okay, as a result of which they collide with each other and also with the walls of the container. Hence their velocity and direction of motion continuously changes. So see, for example, there are 50 blind people are standing in a room which is closed and they are constantly moving. What will happen? They will collide with each other. In the same way, they will collide with the walls. In the same way, now gas molecules are moving in all possible directions but in straight line with the high velocities. What will happen? They will collide with each other and they will collide with the walls of the container which you had taken. Okay, so because of that, the direction, okay, and the motion continuously changes for gas molecules. Now coming to the fourth point. The actual volume occupied by the gas is negligible when compared to the total volume of the gas. This point is very, very important. Remember, the actual volume, let us think this is a beaker, it occupied some volume. The actual volume occupied by a gas molecules is negligible when compared to the total volume of the gas. That means, for example, if you had taken a container, okay, 1 liter container, so what will happen here? The gas will occupy 1 liter. And now if you are taking 2 liters container and if you are taking the same gas here 1 liter, it will occupy 2 liters. Okay, that is the meaning of the point. Now coming to the fifth point. There are no attractions or repulsion among the gas molecules. Okay, so because of that only they spread easily in all directions faster, means the diffusion property will be more. Now coming to the sixth point. There is no loss of kinetic energy when the gas molecules collide with each other or with the walls of the container. So no loss of kinetic energy when they collide with the walls or when they collide with each other or when they collide with walls. Let us think this is the wall, when they collide with the wall or when they collide with each other. Okay, now coming to the seventh point. Seventh point is the pressure exerted by the gas is due to bombardment of the gas molecules with the walls of the container. So, if you had taken a balloon, when you blow the balloon, it bulges out, and when you poke this balloon with a needle anywhere upon the surface, it will blast. That means the gas molecules which collide with the walls of the container, okay, with the pressure acquired when you poke with a needle, it will blast because of the pressure or with the bombardment of the molecules upon the walls of the container. Now coming to the eighth point. The average kinetic energy of the gas molecules is directly proportional to the absolute temperature, that is Ke is directly proportional to T. Okay, coming to the ninth one. Why I discussed this one means, so see, when if you have taken a beaker, I am telling about water molecules, beaker, and you have taken water in this one, then what will happen? You can't able to see the movement of the molecules in the water because it is still. When you kept this beaker of water upon a stove, after some time you can see the movement of the molecules, because as the temperature increases, the kinetic energy of the molecules also increases. So because of that increase in the kinetic energy, you can see the movement of the molecules. Coming to the ninth one and the last one, there is no gravitational force of attraction between the motion of gas molecules. No gravity. Okay, so this is very easy to remember. First one, every gas molecule consists of a large number of tiny particles called as molecules. And next one, we have to describe about the nature of the molecules. The gas molecules are considered as hard, spherical and perfectly elastic. Third one, gas molecules can move in all possible directions but in straight line with the high velocities. As a result, they will collide with each other and they will collide with the walls of the container. And now coming to this one, so gas molecules, the actual volume occupied by the gas molecules is negligible when compared with the total molecules of the gas. Now coming to the fifth one, there is no attraction repulsion among the gas molecules. Coming to the sixth one, no loss of kinetic energy when they collide with the walls of the container or when they collide with each other. And coming to the seventh one, the pressure exerted by the gas due to the bombardment of the gas molecules with the walls of the container. And eighth one, the kinetic energy or the average kinetic energy of the gas molecules is directly proportional to the absolute temperature. And ninth one, there will not be any gravitational force of attraction on the molecules of the gas. Okay, thank you.